So the semester exam review for our final. Samantha works at a coffee shop. She works 4 hours a day. 1 week she takes 3 days off. Show how much she works across 2 weeks using a graph or a table. So 1 day, 4 hours. 2 days, 8 hours. 3 days, 12 hours. 4 days, 16 hours. 5 days, that'd be 20. 6 would be 24. 7 would be 28 hours of work if she's working every single day. Then the next week, we'll say this is when she takes her days off. So 1 day she gets up to 32. The second day she takes off. She stays at 32. The third day she stays at 32 again. That's 2 days in a row off. And then she'll take this one off, stay at 32. Fifth day, 36. Sixth day, 40. Seventh day, 44. So what happens to the graph or the table during the time she has off? It stays where it is. It does not continue to go up because of what the lack of work. Y is an equation not the best way to represent this problem. If you did this problem with a y is equal to 4x and said she's going to work 4 hours every single day, you can't add in the day off. Two trains are moving towards each other at 60 miles an hour. They're going towards Chicago. If one starts 70 miles away, one starts 100, will they get there at the same time? No. It's going to take one of them 1 hour and 10 minutes. It's going to take the other one 1 hour and 40 minutes. On the third one, if you have $50 on your lunch account and lunch costs $2.75 each day, could you find when you would run out of money on the account, and how would you represent that? The easiest way is to take 50 divided by 2.75, but you're not going to come up with a whole number, okay? If we grab one of the calculators real quick and just run through that, 50 divided by 2.75 is going to come up to 18.18 repeating. So it's going to take 18 days. But you are going to have money left over. You'd have 50 cents left over. So will it be an exact day or amount when you run out? No, it's not going to be. All right? It's going to come out, you have 18 days to go by and then you got 50 cents, so you could maybe buy a cookie, a drink, something like that. Number 4, Mr. Wyrick has decided to get in shape. He starts with 10 push-ups a day, then after a week doubles the push-ups to 20. How many push-ups will he have done total at the end of 2 weeks? So we do 10 every day for 7 days. So we go 10, 20, 30, 40, 50, 60, and 70 total push-ups. But then we start going up by 20. So it goes 90, 110, 130, 150, 170, 190. And then, is that it? Or is that 1, 2, 3, 4, 5, 6? One more, 210. So end up with 210 push-ups. Is there an equation that can be written for this pattern? Not really. Not one that we would have come upon. Not one that's going to make much sense. It's going to be a complex equation. It's going to be a piecewise function. The slope changes partway through it. It's easier to just total the whole thing out. I'm posting a video of this. So it's okay if you missed one. You can go back and look at it. In business, you only turn a profit when your sales exceed the amount that you have to spend. If Kroger does $100,000 worth of business, that's $100,000 that'd be up here in the black. 450 hours of work from the employees at 12 an hour. 450 times 12 is going to be minus 5,400. 50,000 for stock is going to be minus 50,000. And 10,000 to expiring stuff or loss. There we go. So how much profit would they make? You subtract all of the rest of these, you come up with like 36,000. Okay? It's not an exact number that I put up there. You can do the math and come up with the exact number. But just understand, there's going to be a question on the test about like somebody having to buy something to get their business started, and then they charge however much per. They're not making a profit until they have made enough money to overcome that deficit from when they were getting started. The next section, like these are pulled directly from the reviews we had on previous tests. Sketch a graph of this table. It's going to go down from 20 to 8 as it goes. Would this graph be linear or nonlinear? It's linear. It's changing by 4 every single time, and this is changing by 5 every single time. So it's linear. It's a straight line. Should this graph be discrete or continuous? It should be discrete. If all you have is a table and you don't have any information about that table, like this is how much a plant is growing or this is how much money is going away from your account, you can't say, oh, I should connect these dots or whatever. So because it's just the table, we don't know if the values in between are true, so it's going to be discrete. On this one, 0, 0, 2, 2, 8, 4, 18, 6, like it's not, this one, this changes by 2, then 2, then 2, this changes by 2, then 6, then 10. Okay, so this one's definitely going weird. Would this graph be linear or nonlinear? It's nonlinear, all right? Because it doesn't change by an even every single time, or the same number every single time, it's not going to be a straight line. It's nonlinear. Should it be discrete or continuous? Again, it's just a table. Because it's just a table, it will be discrete. If it's ever just a table, it's always going to be discrete. Unless the labels on that table make sense for us to not make it discrete. D of T models Harry's remaining debt in dollars as a function of time. Graph the situation. If you scale the graph out on this one, it's kind of like this. He's paying $200 a month. Is this graph linear or nonlinear? It's definitely linear. He's going to be paying $200 every month on that total debt of $9,000. Should this graph be discrete or continuous? This one should be discrete. He is making separate payments, one per month. And it's not like a fraction of a penny every second to where all these partial values on this one are true. Because he's on that payment plan, he hits those payments and that's it. A ball was thrown in the air. The path of the ball is represented by the equation negative t squared plus 8t. Graph the equation over this on the accompanying grid. Sketch a graph. It looks like this. Okay, this would be 0, 0, and this would be 8, 0. And it kind of goes like that. The ball goes up in the air, comes back down. Would this be linear or nonlinear? It's nonlinear. It is not in a straight line, so it's not linear. Should it be discrete or continuous? This one's continuous. Like all of these points exist. All those fractional values exist because the ball doesn't cease to exist. Okay? What two numbers are going to multiply to 18 and add to make 11? That's 9 and 2. What two numbers multiply to make negative 56, add to make negative 1? That's negative 8, positive 7. What two numbers multiply to make 24, add to make 10? That's 6 and 4. Multiply to make 24, add to make negative 10, it's negative 6, negative 4. Multiply to make negative 24, add to make 2, that's 6 and negative 4. Multiply to make negative 24, add to make negative 2, that's negative 6 and positive 4. And what two numbers are multiplied to make negative 24, add together to make 5? That's a positive 8 and negative 3. We did this one with the little x's like this. If you still want to set that up that way, you can do that. It's like the negative 56 on top, the negative 1 on the bottom, and it came up negative 8 and 7. Your exam for the semester exam will be a multiple choice. So you can choose which one is going to be correct. So it's easier to look at them. But I set these all up to come up to kind of the same thing for a reason. Like these are all 6s and 4s. and the negatives are just kind of traveling around. But it makes a big difference in what they add up to. So make sure you not only multiply them, but also add them to see which answer should be the correct answer there. When you get down to this one, factor them. This is asking you to do the same thing. It's what's going to multiply together to make 12 and add together to make -8. In this case, it's a -2 and a -6. But because we're doing factoring quadratics, that's going to be x minus 6 and x minus 2. Okay, so it's going to end up slightly different. Multiplies together to make 12, adds together to make a +8. That's x plus 2, x plus 6. And this one, the -12, when there's no number here, this is a 1. That's x plus 4 times x minus 3. All right? On the next page, adds together to make 7, multiplies to make a +12. That's x plus 3 times x plus 4. And then multiply together to make 12, add together to make 8. That's x plus 6 and x plus 2. Dave is going to build a fence around an area in his backyard. He wants to maximize the area of the fenced-in zone. He has 200 feet of fencing. He's going to make a rectangle. We did this before, okay? And we talked about it pretty much at length on both the assignment and on the test. The best area is always going to come from having a square. If it's perfectly even on both sides, that's going to maximize the area. If you can't remember it, go ahead and draw a rectangle and think to yourself, okay, it's a rectangle, the opposite sides are the same. If this is 10, this is 10. So then we've got 180 left for a rectangle. This would be 90 and this would be 90. So for our sides, we've got length and width, we've got 10 and 90. For our area, that would give us 900. If we went 20 and 80, that would give us 1,600. If we went 30 and 70, because we only have so much fence, that's 2,100. It keeps going up right until we get to 50-50. That's 2,500. If we go back to 60-40, 40-60 is 2,400, 60-40 goes back down. So this 50-50 is as good as it gets. So what's the maximum area? 2,500 square feet, and the side length would be 50. Netflix charges $12 a month, has 50,000 subscribers. They're going to raise the prices and expect to lose 1,000 subscribers for every 50 cents they raise the price. You can use Desmos on this test. I'll allow you to open up an extra tab. For Desmos, we'll be kind of wandering around monitoring to make sure you're not just trying to screenshot and cheat and look up answers. But this is going to be, Netflix's price is $12, and we are going to add 50 cents for X every time we increase the price. We're going to multiply that by 50,000 minus 1,000 for X. However many times we change the price, that's how many people we're going to lose. So all you'd have to do is set that up in Desmos, multiply it out, and see what that peak thing, the vertex of that quadratic equation is going to be. That's going to be your right answer then. Okay? And I can do a demonstration of this later if we need to. It's just, that's kind of how to set it up. That's how it's going to work. The division of labor stuff. Frank can paint the outside of a house in 12 hours. A speed for Frank is he finishes a 12th of the house every hour. Jimmy can paint it in 8 hours. He finishes an 1/8 of the house every hour. So if we go to put their speeds together, 1/12 of X plus 1/8 of X, we have to convert them to where we can put them together. That's 2 out of 24 plus 3 out of 24, which is 5 out of 24 times X. In order to get one house painted, it's going to take them 24 divided by 5 hours. So 24 hours divided by 5, that's going to give us 4.8 hours, or 4 hours and 48 minutes. Okay, it will be faster than either one of them can go, but it's not going to be quite as fast as if the one who is faster going double. All right, that's kind of the easy way to remember it. Like if both of them went that 8-hour pace and we had both of them working, they'd finish it in 4 hours. It's easy, you just kind of cut it in half. Since the one works slower, he's going to get a little bit more done. He's going to get a little bit less, but it's still quicker than either one of them on their own. Yeah, you had a question?
Right in front of the 48. Like
Oh, this is 4.8.
right below that.
This,
The right one, right, yes, that.
that's 4 hours, 48 minutes.
Okay.
That's what 4.8 hours translates to when you take it to minutes. Same kind of thing with this one. Bruce has 2 pipes in his backyard that run water to fill the pool. The pipe in the deep end runs twice the amount of water. So that's actually 2x plus x is equal to 6. So yeah. If he just runs the slower pipe. So this is at full speed, it takes 6 hours. So we're determining a speed here, which kind of messes up some of your calculations. You know it's going to be a lot slower. It's going to run at 1/3 of the speed, which means it's going to take triple the amount of time. So 1/3 of the speed it's going to take 18 hours. Okay, this is the stuff that we just finished up. So if you did the last project and you kind of understood what was going on, you're in good shape. If you didn't get any of the practice with Desmos, these questions might provide a bit of a tough customer here. Create a quadratic equation that opens downward. That's a negative x minus something squared. Has a vertex of -2. So x minus -2 would be x plus 2 squared, and then plus 4. Now, the beauty part of this is that you will have access to Desmos during the test. So you could go through and graph the different options and see if it does open facing downward and have that vertex. Move that equation up 6, y equals a negative, x plus 2 squared. I add 6 to this, so that's plus 10. Go back to number 1, move it 7 to the left, that'd be adding 7. So y equals a negative, x plus 9 squared plus 4. Okay, just keep some of that stuff in mind. Look at the graphs, make sure you understand what order they're going in. Create a quadratic equation with a vertex of 4, 3. Y is equal to x minus 4 squared plus 3. Move the equation from number 4 up 4 units. That's y is equal to x minus 4 squared plus 7. I can't remember if the test is just quadratics. I think there might be a couple of different graphs, but do you understand what it means to move them? Our table stuff, going kind of back, we did a project for this unit, so we didn't have a true review. The questions will be more like this. We are adding 1 every single time here, so this is 56. On this one, we are subtracting 10, so this is 8. On this one, we're multiplying by 5, so it's 15. On this one, we're dividing by 3, so it's 6. On this one, we are adding 15. So 91 minus 15 is going to be 76. And on this one, we are subtracting 5, so that's going to be a 98. And wow, is that the whole thing? Yeah, that's weird. It pasted an extra copy of the first page onto the back of this one, so check yours. study from this, look over it, and good luck on the test.